Hi, how are you doing? I'm glad. So we're gonna work on our last lab today. Next week we have a couple more things to finish up. So we will meet on Tuesday. And then after that, after this week, we're only gonna meet on Tuesday, okay? So after next Tuesday, it's not mandatory attendance anymore. So I will allow you to use the time to finish your project, wrap up, get ready for the final exam. After next week, I will go over the final review. I think next week is still going to be week 12. So in week 13 and 14, I'm going to go over the final review. Okay.
So Professor, we're not going to have a quiz 3, right?
We are going to have a quiz 3. So I'll release that next week. Because if you go through the quizzes, it's also going to help you for the final. So yeah, we'll talk about that next week. We'll have a last quiz.
So did you release the quiz 3 review?
Not yet. That's gonna come, let me see here. I originally had it in module 12. And since I moved things around, we have to cover chapter 17 because quiz 3 has 17. So I will give you the assignment next week. And then quiz 3 is gonna open after that. Okay. So quiz 3 is gonna be in week 13. 2 weeks from now. You're welcome. So we'll start in a couple minutes. As I was saying, if you just joined that, we are gonna have our last lab today. Next week, we're gonna cover one more chapter. And then instead of a lab, you will have a discussion thread that kind of prepare you for some of the other classes. Because some of the concept in some of the other chapter kind of just, prepare you for the upcoming class. So we don't have to meet on Thursday anymore after today. Next week, I will have a quiz review that's going to be released. And then your last quiz is going to be in week 13. On Tuesday in week 13 and 14th, I will go over the final. So if you want to go over the final review, you're welcome to do that. And final review is part of your homework assignment. So make sure that you get it done if you can't attend the session. For the final exam, it will be released on the last day of class. So for you guys, that will be December, hold on one second, let me check my calendar here. 17th, that will also be the last day to turn in your work and your project. So your part 1, make sure that you complete part 1, okay? All right, so it's 6 o'clock. I'm gonna go ahead and get started. So before we get into the lab, let me share screen. I read through your form that you fill out for the project part 1 for those of you who submitted it. So what I did was I was playing around with Microsoft Teams and I want to introduce the tool to you. So I'll talk a little bit more about it on Tuesday. However, if you look at the module, I put a page in the module for team for project. So I saw that some of you are looking for team members. So what I did was I created different teams. Some of you already filled out the team that you want, but you're not sure. So Enigma, I think Jose and Victor were looking for another member and they're not sure what they're going to be doing yet. So I put the link there. So what you can do is, I'll show you what team would look like real quick. You can download the app and install it. It works on mobile platform and also on your computer. When you authenticated to it, you would use your student email address and you can link everything to your OneDrive. So it's kind of nice. I like it because it helps me track all the activities. So as you can see, I'm part of different teams for work. So what I did was I created, empty teams. And so if you want, you can look at the category of the teams and you can join the team. So that way you can have a place where you can share files, talk to each other, set up, schedule a meeting. You can also do web conference via Microsoft Teams. You don't have to use Zoom. So on the left right here, you have these little buttons where you can manage, you can chat with each other. You can be part of different teams, of course, and then you can drop files. So for example, for the Cascade, we just started the project with the interns. So I have added them into the team. So what I can do is I can post something to it, right? Which I started some conversation with them. And then I can upload some kind of files in here. And what it'll do is it'll let you drag in the files that you want, or you can link it to your SharePoint, which is your OneDrive. And then, or you can copy a link if you use your Google Drive. So however you wanted to do that, it's kind of like a centralized place for you to manage your task. And then you can load your calendar and to be able to set up an appointment. You can make a web call. There's a lot of different things you can incorporate. And then if you can bring in your other Microsoft apps, if you like. So now it has a planner component. I play with this a little bit. It's a little bit clunky. I don't think they work it out all yet. However, if you wanted to add different apps in it, you can. I mainly use for file sharing with the group that I work with. And then I also use it to chat to different people in the team. And you can always leave the team when you're done. So it's pretty nice. That's like one of the tools you can use. Of course, there are other tools like Slack and different things that you can use online, whichever would be best for your group. So if you're looking for a team in the course project module, I set up the link. So I made 2 teams for Blackjack. I can always add more if you like. And the maximum I'll take for the team is 4. The minimum, if you want, you can work by yourself or you can work with another person. So from 1 to 4, I'm fine. Now, make sure that we complete the first part of the project, which is to fill out. I kind of wanted to gauge and see what you're going to be doing. And then once you have that established, if you find someone to work with, you can start working on your project. So on Tuesday next week, I'll go over some of the concept that we still need to cover in chapter 17. I'll walk you over on, looking at GitHub and how to be able to get your GitHub started if you don't have GitHub, and then a little bit on the Google Sites on how you can set up your ePortfolio and link stuff over. So we're going to talk a little bit about that. after we cover the session. And again, we're not going to have lab next week. There will be a discussion thread, so you are expected to host some form of discussion. It's going to be related to some of the computer science theory. So I will add that as next week, okay? And then the following week, I will do final review on Tuesday. So on Thursday, please dedicate that time to do your project. Now, for those of you who go through the project and then you find out that, you know, last minute you cannot get things completed, I still want you to submit it, submit all parts. Otherwise, you're going to take a hit on your project. Even if you score well on the final, your grade might plummet. So I just want to make sure that you get your project done. Okay. And I'm available during office hours. And I open these teams so you can add each other as well, but you can also chat with me on Teams. So if you're in the team, if you have questions, you can send a chat message. I'm usually on my computer for most part, so I'll be able to answer. If not, you can also send email, okay, or Canvas message. So you have multiple ways to contact me. All right, so let's talk about the lab on what we have to do today. So we are going to do Unit 11 lab, and this is on Caesar Cipher. So I want to show you how you can work with Caesar Cipher. And so you can base your Visioneer on a lot of this, so you can see different technique and how you can write a ciphering program, well, mainly for substitution with shifting. So we are going to do lab 11. Okay. Sorry, it says 12 on there, but it should be 11. Let me see. Hold on one second. Let me check to make sure that I have the right version. Okay. So let me zoom in and then we'll touch on some of the programs here. So as of Tuesday, we talked about, chapter 5 talks about encryption and how to shift characters. So we touch on Caesar Cipher, which is a substitution encryption. Now, we mainly work with alphabet, our English alphabet, which is A through Z. So in the first part of the lab, it talks about how you would look at the equation to implement the shift. So to encrypt, your function would be X, which is going to be your message or your text, plus N, which is going to be your key, how many shift spaces or shift character you want it to include. So if I'm shifting 6 places down the alphabet, I would do a +6. And you can write it as a variable in C++ and then assign that variable the value. And we wanted to do a modular 6. So a modulus 6, or I'm sorry, 26. And 26 would be our number of characters in that alphabet. So it gives you that range on, on the alphabet, the English alphabet. So now if you're working with different type of alphabet, you would consider the multiplication in this number. So once we encrypt, we can decrypt the message, and our function would be that you have the message that's stored in the X variable. We would subtract the shift key, which is the places that we would shift in the alphabet. And again, we would do a mod 6 or a mod 26. I don't know why I keep saying mod 6 today. A mod 26. So after we encrypt, we wanted to see out, right? We wanted to be able to display what the ciphertext would be. And then if you wanted to test your decryption, you can take that ciphertext, plug it in, and to see if your program, the function of your program works in decrypting. Now for the project, when you're working with this on the project, remember that Visioneer is a little different where you're using the key to cross-section it. So we want it to encrypt and decrypt, okay? So let me open up my first program. So here's the program for the first one. And in this one, we're gonna do the cipher and our phrase. Our message is attack at once. We're gonna do a shift 4. So our int s here really represents the number of places that we're gonna shift each of the character. And then I'll explain the top on what that means. And we would see out the message, the plain text message to start, the shift, and the ciphertext. So at the top, what you have is you have the function called string, it calls encrypt, and it's a string type. So with this function, your parameter is going to be the text, which is the plain text message, and the shift key. And so we wanted to traverse through the text by using the loop, so it iterates through the string. And as you know, string contains the sequence of your characters, okay? So now in this one, what it's doing here is that it's forcing it to a certain case. We wanted to force it into uppercase. Why is this? Because the way it's used here is that they're using the Ascii equivalents. So if you open up like an Ascii table, you can see, so in the Ascii table, we can see that 65 is A, okay? So the decimal equivalence is of A is 65, okay? So this is why when you look at this, so what it's saying is that it's gonna treat A as the first character in that alphabet. Okay, so this is why they're adding 65 and subtracting 65, then mod 26. So in this statement right here, it says if is upper text index. So we have to index every single character in that string, and we wanted to take each of the character and we wanted to shift it. So instead of treating it as a character, what it's doing is it's converting it from character to an integer, which is a number. And it's using the decimal equivalents of that character. And you notice that the uppercase A is at 65 and the lowercase a is at 97. So in this program, they're only using uppercase. So this is why it's forcing it to be an upper, okay? Now it starts with the letter A, capital A. So that's why you see the 65 being used here, and with mod 26. Now what happens if I wanted to use the lowercase instead, then you would use 97, okay? Now, what if I wanted to use uppercase and lowercase? Then what you have to do is you have to adjust that range to contain both upper letter value and lowercase letter value, okay? Now, this is only one approach. Keep in mind that you don't have to do it this way, right? So this line right here is for the uppercases character. This line right here is for the lowercase characters. That's why you see the 97 being used. So as it traverses through the text, it's going to check, right? If it's uppercase, it's going to use this, okay? And then if otherwise else, for the lowercase letter, it's going to use this. Now, the limitation with some of the Cipher shift program is that you see, you know that ASCII only goes up to a certain range, right? We would reach after, if we have decimal that's higher than 127, it could not interpret it. So it's only going to be used within this range. So now we're, and if you're only doing the characters, then it won't be able to interpret symbols. So if the user put in comma or you know, some kind of characters that's outside of the alphabet A, B, C through A through Z, then it won't be able to know what that is. So the deficiency in this program is that we don't have a way to really control some of the input. So we have to think about how we can improve this to do input validation. Okay, so when we run this program, what you would see is that here is the phrase to start with, the word. It's going to shift 4 and it's going to give you this output. Okay. Now, simply after we return the result from that function, we would call that function in the main. And of course, in the main, you would declare your variable text and assign it whatever string you want. So this one doesn't have any form of input either. And in reality, that if you want a cryptography program to be fully functional, we don't really hard code this, and we want it to have some kind of input from the user. Okay, so in the next few program, you're going to see that. So now the shift key, it uses the int s here, as we mentioned, and then we simply do the cout and we call on our function at the end there, and that will conclude the program. So now when you go through this, with the first example, we can put it into our IDE and run it. Okay. Then I see a question. You should, yeah, it's a string object, so you can. So you can include string. You don't have to, because even with the cout, even the IO stream and just the standard, it has incorporated string in this, so it should be able to type it. Yeah, so now if you wanted to treat it like a string object, yeah, so you don't have to include string, but you can. Okay, it won't change much. So for our program, after we wrote it, right, we would look at the program and we would ask how many characters is shifted. So as we look through the program, we know that it uses int s, which is 4. So it's doing a shift 4. And that means it's going to shift 4 to the right. So it's going to move. So if I have attack with starting with an A, right? Then it's going to go 1, 2, 3, 4. So the A becomes, it substitute that with the E. Now, since our message is all uppercase, right? It's going to produce uppercase. That's why when you see the statement that shows is upper, right? It's converting that for the uppercase. So that's why we see this as the output. All right. And then, so as you look through the program, you can determine that it shifted 4, then for B, right? I just want you to verify that the program output the right cipher. So for the B to answer it, I just want you to double check to see if you get the same manual substitution with the program. So if we say that we have attack at once, right? We can say that it will be E, and then for T is going to give you XX, right? Because T, if we count 4 places, that's going to land on X. So we would have XX, and then again E, because the next letter is the A here. And then for your C, that will be G, and so forth. Okay, so you can complete that. So once you manually check it, see if you can confirm that it gives you the right value. Then I want you to edit your program, use a different shift value and a different plain text string. Run the program and give me a screen capture. And what will be your output. So answer the questions for C. So for my program, let's say that I don't want to use attack at once. Let's say that I want to use, and let's throw something in there and see if it works. Okay, so I'm going to use an exclamation point to see if it sees the symbol. And let's say I wanted to shift 6. Okay. So as it looks at my symbol, it gives me the square brace. Okay. And in this one, I shifted 6. And you can make it higher if you like to see if it shifts correctly. So you can play with it a little bit and so you can have a better understanding. So in this one, it's simply use a for loop with the nested if, right? If else to encrypt. And it converts it to the decimal value of the Ascii equivalents to the characters instead of just using char. Okay, so it treats the string like an array of characters and it iterates through it using a for loop, and then it checks for uppercase and lowercase so it can output the right format. Any question with exercise 1? I think I mislabeled the example. Sorry. I don't know why. I must have been tired. Okay. So after you edit the program, change the shift value and the string, run the program, take a screen capture, right? What's the shift value, plain text string, and output. Then for D, I want you to identify the section of the program where the cryptography functionality exists. So we talked about the for loop, the if-else statement. Give me a brief explanation on what it's doing. Okay, so put down the answer for D. Any question with exercise 1? So question Carlos said, why is it adding 65 and subtracting 65? Okay, 65 in the Ascii table, the decimal 65, integer 65 is an uppercase A. So what it's doing is it's saying that A is the first character in the alphabet. Okay. Now, when we do the 97, that's the same thing. That will be the lowercase a. Now, why doesn't it just add the 65? Well, adding the 65 would just be the a. But when you add and subtract 65, you get a 0. And at index 0, that's going to be the a. So here at the 97, that will be your lowercase a. So when you look at the program, it's indexing the character and it's converting it to an integer. Okay. Because char, right? So it comes in, it stores it as letters, so it converts it to a decimal value, and it needs to do the computation with the decimal value. So that way, and then it would add the shift. Okay. So if you look at it, right, first it subtracted 65, it offsets that, and it adds to 65. So what happens is, so if I'm adding a 4, that will give me a 69, that will be an E. Okay. So when it adds it and subtract it, it converts it back. So what we have is we have the A, and when it adds the shift, it's at the E. So in that sense, what we're doing is we're able to take the character, convert it to a value, operate the math, and then convert it back into text. Okay. And it's a long way of doing it. You can simply just use char, which is what you see in the next one, but that's how you can also approach it, is to treat it as a decimal value of that character equivalence. Okay. Okay. So for the second part, this right here is the lowercase a. So it's saying that starts at the lowercase a for the lowercase letter. Okay, any other questions? I see a lot of students, they do it this way, right? Because they can, they can see it on the Ascii table. So when you're doing a shift, you can see if you plus 4 where it's going to be, if you plus 8 where it's going to be. Now, when you get to, so let's say that if you're using like a Z, 122, okay? And if you, let's say if I shift higher than 6, let's say I shift 8, if you don't do it correctly, it would reach the ceiling because it's at 128. So you have to find a way to convert it only as character instead of having additional symbols. So the limitation with doing it this way is that you got the max at 127. in the decimal value for ASCII. Okay, so anything else on number 1? Let's talk about number 2. So for number 2, this is a Caesar shift. Okay, let me open it up on REPL here. Okay, so this one is very simple. Simple in the fact that, like, you know, but you see a little bit of a different approach. So you have char message, so it's going to contain up to 100 characters. This is an array that will store up to 100 characters. Okay. And then what it's going to do is going to see out, right? Enter the message to encrypt to the user. As the user type that in, it's going to store that back into the array. Okay. And then and then it's going to ask for the shift key, and it's going to store that into key. So like the other one, it uses the for loop. It's going to iterate through. Okay. So for the messages not blank, it's going to iterate through every single character. Okay. So it's going to go all the way up to, right, the end of that input. So then we implement the if. So if character is A or greater or equal to A and less than or equal to Z, it's going to take that character and it's going to add the key. If character is greater than Z, it's going to loop back to A. So that way we control it, right? We put it in that range from A through Z. And when it reaches Z, it's going to come back. Okay. And then we have an else if for the uppercase, right? Character is greater than or equal to uppercase A, and character is less than or equal to uppercase Z. It's going to operate the character by adding the key. And again, when it reaches Z, it's going to return it back. It's going to come back to the beginning of the alphabet. And then we're going to see out the encrypted message. Okay, so here, let's say it asked me to enter the message. Okay, so let's say I put computer uppercase, shift value. Let's say we do a shift 5. Okay, it gives me that. If we run it again, if we do lowercase computer, if we do a shift 5, right, it gives me that. So as you can see, the parallel in the uppercase and the lowercase in this one, right? So what we have is we have the lower, if you have it lowercase, then it's going to output the lowercase. And we simply use the conditional statement to get it to output what we wanted here. Okay. Now, after you have entered this into the IDE, I wanted you to test it. We are Klingons. Okay. And I want you to shift 13. And I want you to check to see if it gives the right output. So there's also limitation with this program, right? As you can see that when you're looking at shifting 13, it's giving you this at the end. So when you're looking at S, as we look at S, so thinking back about how your computer sees that value, right? It comes in, it would be it would break it down into 0 and 1s, but let's say that lowercase s is at 15 or 115. If we count 13 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 would hit the ceiling at 128. So what happens is at the S for we are Klingons, it doesn't know what that one is. Okay. So it's gonna come back to A, and then it's gonna finish that. So now if you're looking at how the Ascii table is set up, so think about when you implement this onto like Visioneer program or cryptography program that uses shift, right? How the computer really sees the text value, whether it's character, if you use 6597 or you use the character, the limitation and how you write it. Okay. Now, can you make this as a string? Just like the other one, yes, you can have it as a string and you can still iterate through that string. But the way this program is written is that it would store the characters as into an array, and then it would shift based on that. So why did we -1 here? Anybody know? Why do you have Z? I see some answer, I hope. Starts at 0, yep. To human, we say, oh, that's the first letter, but the computer, right? It indexed that, so you would use indexing. So because we are 0 base, not 1 base. Yes, that is correct, Eric. Very good. Okay. So as you see, right, we're using index, and the first element, the first letter is at index 0. So that's why we have to do a subtract 1.
I have a question.
Sure.
So when you're talking about the ceiling, reaching the ceiling on the Ascii table, is it only if it's the exact value? Since for S is at 13, it caps it, but
Yes.
W it does, even though it goes back to A, doesn't affect.
Yeah. So the way that it's written, yes, it did go back to A because they have it when it gets to Z with the if condition, if the character is greater than Z, then it's going to come back to A, and then we have to do the character minus Z plus A. So yes, but if we write it like the previous one, what you're going to see is that when you rotate it higher, so with the previous one, it's going to throw in some stuff if you go lower. And then you saw earlier that it added some of the symbol like I have it, because it added all of these too. So the range that they use it in the last one is a little different. So with the S, we're at the 128. So it did come back to A because what happens is it reached Z and it subtracts it. So because when you're at S, yeah, when you're at S, it's 115 plus 13, that's going to be 128. And so let's say that I'm going to rerun this so you can see. So if we just do SSS like this, and if we do a 13 rotation, see what happens? So it's not spitting it out, because when it subtracts it, when you get, it's supposed to come back to A, right? Right here. But when when we do 115 plus 13, it's going to be 128, and that's the ceiling. So it doesn't have, it can't come back, and it doesn't show any character. So at the end of the Z, we have these symbols, and as you reach the maximum of the Ascii table, that's the limitation of this.
Thank you.
Yeah. Now, we can even try it with something later in the alphabet. Let's say we do ZZZ like this. And let's say if we rotate 13. So anything after S doesn't work. That's my point. So if you have, like if you have T, U, V, X, any of those, it's not going to give you the right cryptography. The way that this is written, of course. So I've had students in the last couple semester, they approach it this way for the Vigenère, and what will happen is they will come across issues, right, with you know, different key length. So when you have a higher key length, sometimes you run into problem based on how you stated the condition for it to iterate. And if you're using ASCII like this, okay. All right, so for 2, test with we are Klingons, review the program and explain to me how the shift cipher is integrated. And we saw that in the for loop with the nested if else if. So we can say that, right, it iterates through the array of characters based on the user input, and it checks for the condition for A through Z, and it adds the key to each of the character. Then, you know, it implements the if. It's supposed to come back after the Z back to the A. So I would tweak this area because we saw that we reached the ASCII table ceiling. Okay. And so there you go. So this section right here is the main functionality of the program. And then I'd like for you to compare example 2 to example 1. Explain to me the differences between the program. Right, they both use for loop to iterate through the characters, but the way the first program is that it uses the value, the decimal equivalents of each of the characters. So it converts it, right? We had it parsed into an integer, and we use that integer as the equivalents in the ASCII for the character. That's why you see 65 and 97. In example 2 program, in the second program, it's simply just use char, an array of characters, and apply the shift as it iterates through. However, we come across challenges in that anything after the letter S doesn't cipher. Now, the reason why we are Klingons, the W works here is because the uppercase W is earlier, right? It's at 87. So when you add 13 to that, it's still be able to cipher. But if we were to use lowercase w, it won't be able to for the second program. Any question on number 2? Okay. So on this one, I want to show you the decryption, very similar to the number 2, but it's going in reverse. So this one, it asks the user for a message to decrypt. So let me go back to, let's say, this. I'm going to go ahead and run something to encrypt so that way I don't have to do it twice. So let's say that we use a student, like, so like this, and then we're going to do a shift 10. Okay, so I'm going to go ahead and copy this. Come back to number 3. So we are going to do, here's my, let's see if I can paste this. It remembered the last one. But anyway, so let's say, we're just going to put in arbitrary value F. You can use the one from the beginning, right? EXX, T, etc. Okay. So we're going to do a shift 4. Okay. So in this one, like the number 2, we have an array of character, call message. We use the get line to store whatever the user input up to 100 characters. We ask for the shift key. We store that into key. It uses the for loop to iterate through the character. Okay. Now, unlike the last one, it subtract the keys here. Okay. In the last one, when we encrypt, we add the key. We shift it right. Now, when we decrypt, we shift it left. So we have to subtract the key. Okay. So after we apply the conditions, like what we saw earlier, when it gets through, so we have, when it's less than A, the character is going to be Z minus A plus 1. Okay. Because now we're going the other way. And your message is going to be stored in CH. If else, if the character is greater than or equal to capital A, and if it's less than or equal to capital Z, it's going to take that, subtract the key, so it's shifted left, right? If it's less than A, then it's going to be Z minus A minus the character plus 1. So I check the decryption. When we shift forward, that works. So now, right, what we wanted to do is we wanted to put this in, shift it 6 places, explain the functionality of the program. So if we take just the word crypto, which is plain text actually, and if we shift it 6, and as you can see, when it gets to, again, right, when it, because I'm using all capital letters, so the capital C is here. Okay, so when I move it 6 places back, it's actually getting into the symbol and it doesn't know. So if we go C, 1, 2, 3, 4, 5, 6. So it should have given me like an equal sign, but the way this program is written, right, it did not include symbols. So that's why you see the front as something that it doesn't know. Okay. It's a position, but it can't interpret that character. So just like how we see when it gets to the end, right? In this case, it also reaches the limit after or before the capital A. So when you have capital C, right, going back 6 places, it can't interpret the symbol, anything before capital A. Okay. So if we do something like all A, it doesn't know what that is. It can't encrypt that or give you something converted back into Ascii that would be adequate. So that's a limitation with this one. Okay. So run the program, test it. You can use crypto with 6 places so you can see the capital C doesn't work, right? Explain the functionality of the decryption. Compare the program to the last program. What are the similarities and differences? We just touch on that. Since my compiler just pop out A as equal for the lowercase a or the uppercase A? Oh, for crypto shifting 6? Okay, so you're getting the same? Let me test it again. I want you to try with capital letters like capital A and C, like this, like triple A. So let me see. Shift 6. Yeah, on REPL, it's not able to get the symbol for the first one. So for crypto. Okay, so you guys are getting all the capital. Yeah, so for me, the if the else statement is a small a. Let me see if there's some differences. Hold on. Oh, right here. I see what you're saying. It's like this, right? That's what you're saying. Let's see. Yeah, it's not. Let me double check and see. CHA. Yeah, it should be a capital here. Let's see. When A is greater than, okay, less than A minus. Oh, I see what you're saying. Thank you for seeing that. It's greater than this. Well, it's less than in the doc. Maybe that's the reason why I'm getting. Okay. Thank you. I don't know what happened. I think I must have changed it by accident between, yeah, when I copied this, so that was correct. And then, yeah, this should be a capital A though. So I must have fixed it. And then when I took a snapshot, I don't know what, I think I might have modified it somehow throughout time. But yep. So here we are. So yeah, you're right. You got it. Okay. Okay, so for after we test it, we explain the functionality, we would compare the differences and the similarity between the this program and exercise 2. Of course, one is encryption and one is decryption, but the approach is about the same, right? So together, you can actually put it together and make it encrypt and decrypt at the same time. Okay. Now, the true difference for the encryption and the decryption that I want you to see is that the decryption subtract the key and the encryption adds the key. It's shift right and decryption shift left. Okay, so on the next one, this one is a little different. Example 4. This one is using string. Okay, let me open up 4. So now we have a function called string encrypt. And in the definition of that function, okay, we would have the encrypted is going to be source. So in the main, we declare source and key. So you are going to get the message that the user input and then store it in source. And then get the input key, put that in key. And then in the function itself, we're going to use a for loop. We're going to go all the way to the end of that message length, which is called current. And so for each of the character that will be current, so it's going to iterate through each of the character after the user input. And then it's just going to add the key. Okay. So here we go. So if we do, let's do 13. So on this one, the range of this is larger, of course, right? As you can see, it would include symbols, letter. Now I wanted to test it with the space to see if it does the white space as well. Okay. So it doesn't see space as space, right? So here what we have is we can test it with different message, and we can also see how it would shift. So again, it has the function, and for the function, it's going to iterate through the characters in the string, and it's going to add the key because it's encrypting. Okay, and then we just simply return that. So for number 4, I want you to put in substitution, shift it 5 places. Review the program and identify the section that will be the main functionality of the encryption. And let's compare it to the first 2, right? All of them we're using, when we do Caesar shift, we just simply add the key, and they all use for loop, right? In this last one, we have a function that's for that. In the first one, it does too. Okay, but in the first one, it parse it back. It parse it as an integer. So when you have that string stored, right, it converts that into a decimal value, and it used the decimal value to shift. Whereas the number 4, we simply use string, and we iterate through the character of the string. Okay. So I want you to test it with this, shift 5 places, look at the functionality, compare the programs, and that will be for 4. I think I forgot to move this, so let me look for the last one real quick. Okay. Okay. Any question on exercise 4? Last one we did. Let's talk about number 5 then. Okay. So in number 5, you have char Caesar. This is going to be your function, and in your main, you have a string input. Okay. So, and you have a do while. So now if we look closer in how that would be before we come back to the main here. So in the function Caesar, it says if it is alpha, okay, it's going to convert it to upper. So, you know, whatever that the user input, it's going to convert it to upper, because again, right, we're using the decimal equivalents of the character, which is 65 for the A, and that's the first character for our range. And it's going to do a shift 13. So this is an ROT 13, rotation 13, and mod 26. Now in the do while, right, it's going to ask the user to enter the cipher text and press enter. So they should say enter a message actually, right? If they don't put anything, it's going to quit. We have a get line, store it, and then we have a for loop. It's going to go to the end of that message length. And it's as it iterates through, it's going to put it onto the output. And for the while, mainly we wanted to check, right? If it's blank, if it's 0, then it will just quit. So here, let's say that we can input, I think I have you guys enter a message. We would do a characters. Okay. And as you see, it forces all the lowercase to the uppercase. So you only output uppercase. So in this one, doesn't matter what your message would be. Everything as it encrypted, it will be in uppercase. Okay. Now it does check for alpha. So let's try to see if, let's say if I do 1, 2, 3, right, char. So it doesn't convert my number, or it doesn't encrypt my number, as you can see. Okay. So if I do put in a numerical value, it gives me the same exact thing, but it did convert, it did shift my characters, and it gives me the uppercase. And it shifted 13, as you can see here. Okay. So this if statement, check to see if it's an alphabet, right? Which is character or alphabet characters, then we would change that to all uppercase, then use that to do the shift starting at capital A, and then we're going to rotate 13. So let's try something. Okay. And that kind of removes some of the limitation, but then again, we're only going to have everything all uppercase. So on the last one, look at where it shifts. answer the question, what is the shift value of the program? Does the program encrypt symbol or special character? So you can try that. Okay, so we can try it. Okay, so let's see if I do. So no, right? And as we know that it has this statement in here. So it has to only, it can only use characters that would be letters. And then look at the program for question C after you test characters. Review the program and identify the main functionality of the program. Explain how it shifts. Compare this program to the last one. What's the differences? So this kind of gives you different approaches on how to create shift cipher program. And since we have a little bit of time, let me show you some. I do have some of the project stuff stored on here, so let's see. This is from the last semester. Let me see if this one was fully functional. Yeah, this one was not. I think this one was dead. So they got it. It's just, I think that team got partial credit, but let me see if I can find. I did have like some of the good ones, so I'll link that to your module later on so you can see. Yeah, this one I forgot I have to add in the file. So this one was from 2018. Let's see if I can pull this down for you to see. Kind of look like what it would be. So on this one, they did it kind of like what you've seen in the Caesar cipher, right? They forced it to is upper. And it also actually, they check for is upper and is lower. And then it has the decryption portion. Here. Oh, sorry. What does it say? And put a string, so string. Yep. So yes. And then we can decrypt it from there. So this is a fully functional one from a project from 2018 for Visionaire. Okay. And I'll share with you some of that down the line. Any questions as far as the lab goes? Pretty easy, last one. So the only thing that we have to kind of talk about on Tuesday is going to be your chapter 17. So if you have a chance, look it over. We're going to touch on relations, and then the discussion is going to be on automata. Okay. We have one assignment, and then I have a homework assignment. That's going to be a quiz review. There's going to be a quiz and extra credit, of course. That will be the last one. And then the following Tuesday and after that, 13 and 14, I will go over the 2 final review. And if you can't make that, make sure that you complete them, because, you know, that's part of your homework assignment. Then I will release your final exam on the 17th. It will open on the 17th. You have that entire day to take it at any time. Okay. And your project is also due on the 17th. If you want to join a team, make sure you click there, and then you can set up your team, or you can talk to people in the class, or if you wanted to do it by yourself, make sure that you complete it. Okay. Now I've had students that are in the B range and they opted not to turn in the project. They ended up getting much lower grades. Even with the extra credit added, I can only help you so much with extra credit. I can't give you 100% for your project that you never turn in with just the extra credit stuff that you worked on. So it wouldn't be fair to all the other students that submitted it. So don't rely fully on the extra credit for the missing project. There might be some points that will go into that, but it cannot elevate your grade if you don't turn it in. Okay, so the whole point is to be able to help you understand on how to solve a problem with the programming and implementing what we've been learning in your programming. Okay. Do you have any questions for me before we end? Okay, so no question. So I will see you next Tuesday. Don't forget, no class on Thursday or no class meeting on Thursday. Just work on your things. I'm available. If you have question and you want me to get on, just let me know. I can just, you know, use the same link and I can be on it if you have questions. And then I can show you some example of the project down the line, but I want you to work on it and figure out how you be able to write the programs. Okay. Yeah, type in your name in the chat. I'll stick around for questions if you have questions. Thank you for attending tonight. I'll see you next week. You okay? Any questions? For the course project and then Empire solar sales, we're assuming no duplicates. Yeah, no duplicates. So we wouldn't have the salesman going to Paris and no more. No. Yeah, so you can just have one unique route. That's right, Albert. Okay. All right. Good night. Have a good one. Thank you, David. Have a good night.